Oh my gosh. Kelsey pushes the box. She exerts a force. What must be the coefficient? This is just like the previous problem. Let's approach it with a renewed vigor here. Let's see. So I think what we're going to do is we're going to solve an F equals ma problem. Right? We've got this box. Right? She's going to exert 213 this way. There's going to be some unknown force. We'll find that. That'll be the force of friction, right? And then we'll use force of friction is mu times m times g, right? So this is mu times the normal force, right? Okay, so what we'll do is we'll solve for this force of friction, and then we'll know the mass in g, and we'll solve for mu. Okay? Okay, so let's set this guy up. Our F equals ma looks like this. We've got F plus 213. Those are our forces, right? That equals 35. And then let's see, it's accelerating to the right, right? It's accelerating that way. So this is positive 22.4, right? Okay, so let's solve for this force of friction. It's going to be this times this minus this. So 35 times 2.4 minus 213, negative 129. Right? So that is not the answer, but it's what we're going to plug in for this. So I put 129 is mu times 35 times 9.81. Okay? Now, the 129 isn't negative here because we don't, this is just a formula for friction. The fact that this friction force was acting to the left, it's not relevant here. Okay? Especially because I don't want a negative coefficient of friction, right? 9.81 in this context is also not negative. It's just the strength of gravity, right? So now we're set. Now we can solve. We can go this guy divided by this, right? So that guy divided by 35 divided by 9.81. And I get, ooh, that's interesting. Okay. I get that the coefficient of friction is 0.3757 and then some change, right? So I guess with 2 sig figs, there it is. Since it's the ratio of force, this would be the force of gravity, that would be the force of friction, force to force, right? Friction force to normal force, right? Then it's just a pure number. Like radians. I really like Mr. Wickman.